So, let's continue with our tutorial on Hibernate Reactive and Eclipse Vertx. In the previous section of this tutorial, we tested our code against a real PostgreSQL server that was running on a local host. In this section, I will introduce you to a library that is called TestContainers, which is a very convenient solution to write integration tests for Java applications. So basically what this library does, it will run an external dependency. Commonly it is a database server, but not only a database server, in a form of a Docker container with a very limited life cycle. That means the life cycle is limited either to a test class itself or just to a single test case. This is very convenient because each and every test class or each and every test method we will receive a new fresh database, which is very convenient in order to avoid any data collisions that we may have. So the main purpose of TestContainers library is of course writing integration tests, especially for data access layer. But its functionality is not limited because it allows basically to run anything that is available inside, which is available in a form of Docker container alongside with the test. So for this we will use a generic container, but if dependency is quite common, so there is a specific library from TestContainers, like in the case of PostgreSQL, we will use this one. So let's briefly go to documentation, and you see that there are three sections: JUnit 4 Quick Start, JUnit 5 Quick Start, and Spock Quick Start. So because we will use JUnit 5 Jupyter, we will go here, and the system requirements here are quite simple. First thing first, we will need to add TestContainers library itself. The second would be a TestContainers library for each and every dependency that we will use. So in this particular example, we have here Redis, but because we use PostgreSQL, we will use a library for PostgreSQL. And finally, you see here that there is a specific extension for JUnit Jupyter that also should be added to a class path. So without further ado, let's go to MVN repository and let's search for TestContainers. So here you will see these things that we actually need. The first one would be TestContainers core, this one. The second, JUnit Jupyter extension, and finally PostgreSQL. So let's add these dependencies into a class path. So let's go to our IDE and go to pom.xml. Find the dependencies section and add this dependency. And don't forget to sync your pom.xml file. So what I would like to do in this section is to write a simple test with TestContainers in order to demonstrate you how to set up a JUnit 5 test with TestContainers and actually to show that TestContainers library is running. So the topic of writing integration, not only integration tests, but any kind of automated tests with Vertex and for Vertex applications is quite broad. And of course, we will just scratch the surface of this topic. If you are interested in it, if you want to get a deep knowledge of this topic, I highly suggest you to check my book that is called Principles of Vertex, 2nd edition. And the link for this book is available in the description of this tutorial. So without further ado, let's go to the data test package and let's create a new test class that we called TestContainers test. Of course, it is a good practice to make all your test classes with a default access modifier. So first thing first that we need to do, we need to annotate our test with a special annotation that is called TestContainers. So this annotation comes from JUnit Jupyter extension for TestContainers. The next thing is actually to create a container. And again, this annotation container comes from TestContainers JUnit Jupyter extension. So in our case, because we have seen a type of generic container in the previous subsection of this tutorial, we will use a special class that is called PostgreSQL container. We call it container, and in order to create a new instance, we will use a constructor that basically accepts a name for the Docker image that we will use. I will use Postgres 13 Alpine. We also could provide several options, such as the database name. We'll call it whatever you like, because this is containers just running with your test. So you could provide any kind of credentials, any kind of database name. I will call this TestContainers DB with username TCUser and with password TCSecret. So basically, this is all that we need in order to create a test container. Important thing here to remember is the life cycle or life scope of this to be precise of this container. So because our container is not static, basically its lifetime is limited to one specific test method. In order to reuse the same test container with different test methods in the single test class, we need to make it static. However, we will not do it. We will just use an independent container with each and every test. What's the advantage of this technique? Basically, if you're familiar with Django testing, that means that for each and every test, like in Django, we will have a clean database without any previous data. So let's verify that this container is running. Let's create a new test method called TestContainers is running test. So there is a special method for container in order to check that it is deployed, it is created, in other words, and it is running. So let's call the assertion for these two methods. So assert true, container is created, and the second one would be assertion, assert true, container is running. So let's run this test. As you see that test passed, that means that actually the PostgreSQL container is running. So let's see how we could actually use it with tests. Just a few words before we'll continue. I would like to talk about the difference between entity and data transfer object. So what is the difference between these two concepts? Well, in a general sense, entity is a model that reflects business domain specifications in your application. And in most contexts, it will really make no difference between entities and models. However, when it comes to GPA frameworks, they use what is called entity specification. So entity in this kind of frameworks is a POJO that reflects a database data structure. So in other words, POJO equals to a data table structure. And these objects are defined according to several rules. And first and foremost, they are mutable objects. And of course, using mutable objects within reactive applications is certainly no. So what we could do, how we could solve this issue? Well, there is a pattern that is called data transfer object. So data transfer object is also a model, but it is used mainly on a service and a web layer of our application, so it reflects business domain specifications and based on a business domain. Rather, it is not rather based on GPA specification. So of course we could make data transfer objects immutable. And what is important here is that we will use DTO or data transfer objects throughout our application in order to connect different components. Of course, we will still use entities, but we will isolate them inside data layer implementation. So we'll provide mapping between these two concepts, and entities would be used by Hibernate only. So we'll not expose entities outside of data layer implementations. So let's start with the definition of a data layer of our application. So let's go to the model package first, and let's just briefly check the task class. So what we have here, we have an ID, we have a user ID, content, completed, and a created ad. What I'd like to do now is to create a new DTO class. And actually, I will not create a class, but I will use a record, which is basically a syntactic sugar for creating immutable classes. So we call it task.dto. And what I'd like to do here, first of all, I put here an integer for ID, for user ID, string for content. We also have a boolean that is called completed, and finally we have a local datetime that is called created at. So this is a DTO for our data layer. So let's go to a data package and let's create an interface that will define methods for the task repository. We call it task repository. So what we will do here, we need to define several methods. All of them will return an instance of Vertex future, because we should have our repository to be able to be incorporated into a reactive pipeline. So let's call the future. Just be cautious to select a Vertex core future, not from Java util concurrent or from native. And it will return a new task DTO, and we call it createTask. So again, it will accept a task DTO, not a task, because if you remember, we talked just about it, that task is entity. It's a specific Hibernate class. It will not used across our application. Across our application, we will use task DTO. So another method will be update. We will also need a method to remove a task, and in this way we will return a void value, so-called removeTask. And this remove method will accept actually an integer ID, not a task, because as we will see, Hibernate will need an entity in order to delete it. However, in stateless REST APIs, usually we don't have entity beforehand. What we will have a request that contains an ID, delete request with ID of an object. So basically we will delete or remove a task using its ID. We will also need a method to retrieve a single task. And instead of just a task DTO, what we will do, we will wrap result inside an optional. So we call findTasksById. Why we actually do it, it's basically optional, allows us to avoid manual null checking, because if the object is not presented, Hibernate will return a null value, and we need to be cautious about it. We need to check that we have actually a task in order to, for example, manipulate it or to provide a 404 error for a user. Well, technically it's not an error, but 404 result. It's a kind of outcome, which is not a technical error. Yes, it's my mistake, but it is still an outcome that we need to be able to handle. So the final thing we need to have is return a list of tasks. One of common options is to use a list. However, what I would like to do, I would like to create another model class that will be called tasks list. And actually it will not be an interface, but a record, of course. And it will take a list of task DTOs. So you may ask why I use this specific tasks list class instead of returning just a list. Well, there are several issues with returning a list itself. The most important here is that from architectural point of view, we may not need just a list. However, we will need a list with additional data provided by underlying data layer. For example, when it comes to pagination, we need not only a list of tasks, but we also need to have a total number of tasks. We need to be able to check the current page and so forth and so on and so on. So basically all these things accounted are performed by a database layer, by database client or Hibernate inside the data layer. Service layer and especially web layer will have no idea of how these things are computed. They will just need to have these numbers. And in the future, we could extend this task list when we come to pagination with all required parameters. But for now, let's go to task repository and let's return a tasks list. And we say find tasks by user. And you may ask, why actually we have here a list of tasks instead of writing it inside an option like we did in the previous case? Well, basically the tasks list could be empty, and in any way it will return a task list, because as I have told you previously, we may need to return additional values, and these values anyway would be nevertheless the tasks list as a list, of course, as a Java list, could be empty or not. So in this way there will be no sense of making an optional, because we will have a task list, no matter do we have tasks or we don't have it. So this is just my preferred way to construct a data layer, and if you have a different experience, well, you may use it. However, this is a best practice to write things on a data layer by using DTO and by using optionals and by using this specific object for lists. So let's implement this task repository. We call it tasks repository. Actually, we have task repository implementation. And this class will implement a task repository. Of course, we need to implement all these methods that we have defined. And in order to perform operations, what we actually need to have here, we need to have session factory. We call stage session factory. And also it is a good practice to make your classes immutable, final. And what I would like to do, instead of making this manually, I would like to use a record here. And here we will provide a stage session factory, called session factory. And now what we will do, we are allowed to use session factory throughout any methods of our implementation. So let's see how we could actually implement all of these methods. Our next task is to implement a functionality to be able to convert between task entities and task data transfer objects. So from a technical point of view, what we will do, we will implement a mapper pattern. A mapper pattern is a component that allows us to transform between one data type to another data type. And there are several options to organize the code of mapper pattern implementations, and it really depends on your coding practices that are accepted in your team, or requirements of a particular project. So basically what we could do, we could create separate mapping functions inside the task repository implementation, or we could have separate classes that will do this mapping functionality. Well, my personal choice is to have separate classes, because in this way we don't need to depend on task repository implementation if we would like to use these mapping components into other mapping components or into another repositories, so without the necessity to instantiate a task repository implementation, which is very costly because we need to have here session factory. So without further ado, let's go, and inside the data package we will create two classes. The first class would called task entity mapper. And this class should not be public, it should be package private, and it's a good practice to have classes that should not be used outside the package with a default access modifier. So basically we should not use entity mappers or DTO mappers at all, classes outside the data package, because this really depends on our particular implementation of a data layer. And therefore service layer or web layer really do not need this functionality, because they don't have any idea about entities at all. So this mapper class would implement a function interface that comes from Java util function package. This is a number of set of functional interfaces that were introduced in Java 8, so quite a long time ago already. So we have two types here. The first one would be our DTO, so task DTO, and the second one would be entity. And let's implement a method. So this method will accept task DTO, and it will create a new task entity. So what we will do here, first we will create a new task, and then what we will do, we will use setters in order to get values from task DTO and to add them inside a task. So the first one would be set ID. I say task DTO ID. The same will go with user ID. Then we also have content. We also have completed property, so here we have is completed just, and we also have here created property. So say task DTO created add. And finally we will return this task entity object. So this is implementation of a task entity mapper. Its role is to convert between a DTO object to the task. So the next class that we will create we'll call task DTO mapper. And absolutely in the same way we'll make it package private, and we're going to implement same function interface. But unlike what we did here, the first one was task DTO and the second was task. In this implementation we will switch them. The first one would be task and the second one would be task DTO. So this is based on the specification of this interface from Java. So let's implement this method, and what we will do here, we will use this task and we have this task DTO result. So we need to create a new task DTO from this task. How we will do it? Because task DTO is a record, so it is a mutable class, we could not use setters here like we did in task entity mapper. Instead we will use a constructor to pass all properties from task into task DTO. So we return new task DTO and we get all properties from task. So the first one would be get ID, the second one would be user ID, content, completed, and local date time. So this is a component that allows us to convert between a task DTO, between task and task DTO. So we have here these two components that are mappers, and now we could use them with our repository. Now we're ready to implement the first method of our task repository that is called createTask. So as you could notice from the method signature, we have an argument of type taskDTO, and we also have to return taskDTO type as a return type. However, under the hood, what Hibernate does, it employs entities, and entities, as we already mentioned, they are mutable types. And of course, if you work with Spring MVC or any other synchronous environment, it's totally acceptable. However, it should not be done with Vertex, which is a reactive and multi-threading environment, and you always should work with immutable data types. And because we basically have no other choice, we have to use these entities inside this task repository. But as soon as that operation would be completed, we should convert it to the DTO, and we should return DTO to all users of this repository, especially to service layer. Well, let's briefly go to the material of the previous part of our tutorial, and let's go to this Hibernate configuration test file. And here, as you remember, we have the same task entity, and Hibernate, what it actually does, when it's called persist operation, it does not instantiate a new entity instance, rather it uses the same task it just sets an ID using this set ID method, not this one, but set ID method from this class, and we tested it by calling this task get ID before insertion, before this persist operation, and after this operation. So basically it's the same instance. However, we should not do this in Vertex. We should return a new instance because we don't know actually in which thread would be this task entity, and we basically have no such privilege to keep the same instance over and over. So let's return back to task repository. And the first step that I would like to do, I would like to instantiate this task entity mapper class. And we're going to use this entity mapper in order to get a new entity with this DTO instance. So we call entity mapper, apply, and we use this task. The next thing that we're going to do is the same like we did in this Hibernate configuration test. So we will call this persist operation. And remember that return type of this completion stage would be void, because Hibernate would not instantiate a new entity, rather it will modify this entity. And what we will do now, we will call this result session factory with transaction. We have here session, we have here transaction. And what we will do here was called entity. Sorry, we called session, of course, persist, and we persist this entity. But we have to return task detail. What we will do next was future task DTO, we call it future. And what we will do now, we will say future from completion stage. So we'll use this result, but this result is actually a void. And what we will do next, we will call compose. And what we will do now, we will return, actually let's instantiate first task DTO mapper. So it will make our code a little bit more understandable. So what I would like now to do, because we actually could do here, this is the same way it's called here, DTO mapper, apply, and we use this entity. Actually, we need to have here a map. And let's return a future. So basically, this is what we will do once, and how we actually could, this is a very tricky moment here, and I would like to stop here for just a second, because the idea here is that we call this mapping as soon as this transaction would be completed, and so we this one transaction will be completed, and so we know that we actually have persisted this entity into the database, and we have this entity. So this entity has an assigned ID, and so far we could use this this result in our future pipeline, and we could map it to the DTO. So let's check how it will work. Let's verify the behavior of the createTask function. So in our task repository implementation test that I have created for you, let's create a new test method that is called createTaskTest. And it accepts 2 arguments. So the whole idea that we will test here is that we have a manually created task DTO and task DTO object, not entity, of course, it was my mistake, task DTO instance, I would say, task DTO instance without ID. And after we will call the createTask operation, we should have a new task DTO with assigned ID of 1, because we know that we have fresh database in each task method, so the first auto-incremented value would be 1, of course. So let's create a new task DTO that we call task DTO, and let's provide here some values The only thing here is that the first value of ID should be null. Other values could be assigned as you want. So the user ID would be 1, the content would be like my task, completed would be false, and the date and time would be local date time now. So now what we will do, we will call repository and we will create a task. So let's wrap it inside context verify method. So context verify, because we use this context verify block in order to test asynchronous operations. So we call repository, create task, and let's pass task DTO here. Remember that this method returns future, so we should use handlers. Two handlers, one would be on failure for a failed result and one would be on success for successful result. First would be on failure, and here we just will fail the context. And on success, what we will do, we will receive a result, and I would like to verify that this result is not null, of course, and it has ID of 1. So it's assertions. Assert not null result, and we should also assert that not null result ID, and finally we say that assertions assert equals expected to be 1 and result ID should be 1, and finally we will call context complete now. So let's run this test. So as you see, test passed. So now we have a new entity returned by our repository. So by the way, we have here a lot of stuff going on here, lots of red logging in our console. In the next part, we will talk about logging in more like in depth way. But now just don't pay attention to what we have in the right color here. So far, so good. Let's return back to our task repository implementation. And actually the next method that I would like to implement would be findTaskById. Honestly, we need these methods later on in our tests anyway, so we will implement it now. And the second reason to implement it, it's quite interesting because we have here an optional. So, first thing first that I would like to do, I would like to create an entity of DTO, not an entity of course, instance, sorry, the instance of, that was my mistake, of this task DTO mapper. So say task DTO mapper, so DTO mapper, new task DTO mapper, because we need it later on. So session factory session object actually has a specific method that allows us to find quickly find the task by its identifier. Later on, when we're going to findTaskByUser, we're also going to learn about criteria and criteria queries, but for such simple search as search by identifier, Hibernate provides a specific method, so we will use it now. So what we will do now is a completion stage, and we wrap here task, and we call it result, and we call session factory with transaction, the same like we did in the previous case, and now we call session find, and we call task.class, and the identifier would be ID. So what this method will do, it will return a new entity, that's what's found, or in case that we don't have this entity in the database, it will return null. So in our repository, we have to handle such situation. What we will do now, we call a future task DTO, actually task optional, task DTO, call it future. And what we will do, first thing first, as we did before, we say future from completion stage result. And now what we will do, first mapping would be to map this result, so to map this task, which could be potentially a null, to the optional. So first thing was the result, so called R because we have result already. So we say optional of nullable, and we put R here. So now what we have here, we actually have a task wrapped in the optional, but we actually need to have a task DTO. So we call another map, and we say R map, and we use this DTO mapper here. So now what we did, first of all, we converted result into an optional because it potentially could be null, and the second step was to use a mapper to convert the value of this optional, which is of type of task, as you see in my IDE here, into a task DTO. Finally, we just return this future. So now we implemented this findTaskById method. So findTaskById method is implemented, and now we're ready to test it. So let's return back to the implementation test, and let's create a test method. Actually, in this particular section, we will have two tests. One when task does exist, and one when task does not exist. Because remember, we have an optional here. So we need to verify both situations. The first and the simplest situation, when task does not exist. Because we have a new, fresh database, each and every test method, of course, if we don't have anything inserted, we will have no task. We will have just empty database. So let's create a new test that we called void findTaskById does not exist test. So what we will do here, we go straight to the context verify. Because we don't have any kind of preparatory stuff, we have no tasks in database. So we call here repository findTaskById. Feel free to add any task you want, because anyway we have an empty database. So even if we have here insertion, and we know that this would be an ID of 1, like we tested here, because TestContainers will create a new instance of PostgreSQL for each and every test method, we could still use here an ID of 1 and it would not be present. So we say on success, and we also want to provide on failure handler. Context fail no. So let's do assertion. So results, this result would be an optional. So as you see, it would be an optional. So we could check it by using assertions. Assert true, and we say a result is empty. And let's call context complete now. So let's run this test. So this is the easiest task, the easiest task, of course, the easiest test case, the task for us, I mean, not task as an entity. This was an easiest thing in this section. The second one would be find tasks that already exist in a database. As I mentioned it beforehand in this video, and I mentioned it all the time, that what TestContainer does for us, it creates a new entity of, instance of PostgreSQL each and every test method, and basically we don't have this task in the database. What we will do, we will first insert a new task, and another way we will create a test pipeline of several asynchronous methods. So first one will be createTask, and then we will call the findTaskById, and we will check that task was created, and we could check its existence. So without further ado, let's create another test method. But this time I call it findTaskById exists. And if you find this kind of verbal introduction of this idea with TestContainers of that we have a fresh database each and every test method. It's a little bit boring. Well, I just added for people who is not such familiar with Vertex testing, with test container testing, and for them it may be confusing to understand what we actually do here, why we chain this methods together, because the idea of unit testing and integration testing is that we test only one method, and this is true and this is correct from a theoretical point of view. However, we need to assert that we actually have a data in a database and we need to chain and use several methods, which of course will violate the idea of unit testing. And this section is already quite long with this introduction, so let's continue with coding anyway. So the first thing first, let's just copy all this code so we could reuse it. Because what we'll do here, we will first create a task, but instead of asserting the result of create task, we will chain another operation which we'll call repository findTaskById, and the ID would be, of course, the ID of result of this operation. And now inside on success, what we will do, we will actually assert the results of this findTaskById, which is the latest operation in our chain. So we call here assertions. Assert true, result is present, so we know that now we have an optional with a value, and then we call context complete now. And now let's run this test again. And now this test also passed. Okay, let's learn how we could delete tasks. I have opened the documentation again, and in the section 1.3.10, using the reactive session, we have a list of different methods that are provided as a part of session interface. So the number 3 here is remove, and in the description we could see that this method creates a delete statement. So from the first glance it could be what we are looking for. However, if we will pay attention on the method signature, we will see that this remove method actually accepts an object. This is how ORM libraries work. So not only Hibernate or any other GPA compatible framework, but ORM frameworks in general utilize same idea. In order to delete an object, an entity in terms of GPA frameworks, in order to delete an entity, you should have this entity. And then you use this entity, or either you utilize a special methods, for example, how it's done in Django ORM, or you use a session interface and you call the remove method, doesn't matter. But you need to have an entity in order to delete it. This is how ORM works, because this is inherited from the era of MVC applications, where you have sessions, not the sessions of course in terms of Hibernate, but sessions in terms of web development or web programming. So you have sessions and you have different objects within this session, and you have this ability to manipulate objects, delete them, update them, persist, etc. However, when we're working on REST APIs, we don't have such privilege, because REST APIs, they deal with a different idea. You have a delete HTTP statement, and as a part of this delete HTTP statement, you actually pass a path variable with ID of an object. So in order to delete an object using this session remove method, you basically need first to retrieve this object from the database and then to delete it. So apply remove method on this object. It will result in a necessary database call, and what we want to do, we would like to use a delete statement to delete an object using its identifier. In order to do this, we need to scroll down a little bit, and here we have queries. So basically, queries are also part of GPA and Hibernate ecosystem, and this API allows us to use either raw SQL statements like you see here. Either you could use object-oriented API provided by GPA or Hibernate, which is called criteria API. So basically it's part of GPA specification, but Hibernate extends it. So you could use these criteria APIs in order to build type-safe and reusable statements without touching any SQL code. It is very handy, especially for several reasons. First of all, you could avoid problems when you migrate your application to a different database server. You don't need to rewrite SQL statements. Hibernate will do all optimization for you. The second, of course, is type safety. And the third one is security, because using provided by Hibernate API is much safer in order to avoid things like SQL injections. Rather, you will manually concatenate strings in order to create SQL statements. So, without further ado, let's return back to our IDE. And here, let's implement the removeTask method. So, what we need to do? First of all, we need to obtain an instance of criteria builder. So say criteria builder, and pay attention that is part of GPA. So we call it session factory get criteria builder. The second one is to create actually a query. There are different forms of criteria. Actually, there are three of them. One is used for select statements, which is called criteria query. For delete statements, we use criteria delete. And we also use criteria update for update operations. We will see them later on. For now, we will use criteria delete. And don't forget that we need to pass a type here. The type will be, of course, task. So type of our entity. So say criteria delete. And we use criteria builder, create criteria delete. And here we again pass a class of the target entity, which of course will be task class. The next step is to obtain a root, and we could get it by using criteria delete from, say, task class again. The next step that we need to do, we need to pass a predicate. So predicate is a logical condition that is used to evaluate certain expression. So we call predicate, and please be aware that we need to have the predicate from GPA, not the Java functional interface, of course. And basically predicate is a condition, so we use criteria builder, and then we have different types of predicates, of conditions, such as equal and between, exists conjunction, greater than, etc., etc. We will use equal. And here what we will say root get ID, and we pass the ID. So let's briefly stop for a moment and check what we actually did here. So we created this predicate, which is a logical condition, and we use criteria builder in order to build predicate, which basically is same as ID equal to ID. So this ID value actually. So in order to get this ID, which is ID in the SQL statement, we need to use root get ID, which allows us to retrieve a field from our entity class. And in our entity class, this field is called ID. Next step is to call criteria delete where and pass a predicate here. Don't forget to add this step, actually. So what we will have here, we will have here a request for Hibernate to basically construct an SQL statement, which would be like delete from root, in our case will be from tasks, because we specified the table name as a task, where, here you see we have this where, and then we have a predicate where ID is equal to this ID value. So basically, Hibernate will use this API in order to create this SQL statement. It is much safer from type safety perspective, and of course from from security perspective than manually concatenating string, of course. And of course, if you want to later on migrate from, let's say, from PostgreSQL to MySQL, Hibernate will do this migration for you because you don't have any SQL statements. Rather, what do you have here is this object-oriented code. So now we could use this criteria delete and we could execute session. So we say completion stage, and the type now will be integer. So we say session factory with transaction, like we did in all our previous steps. We say session create query. We use this criteria delete. So say criteria delete executes update. So what execute update actually does, it will execute this query, and then it will return a number of affected rows. In our case, it will be an integer, and in our case, it will be either 1 if entity existed and it was removed, or it will be 0 if no entity was in the database. So what we will do next, we'll say future, and in our case, return type should be void. So say future void, say future, here pass result, and then we say compose, and we return future, succeeded future, and finally we need to return this future. So basically this is an implementation of a remove task without using a session.remove method. So now we're ready to test our implementation. Let's create a new test method that will call removeTaskTest. And like in the previous case, this method would also have several steps. So first thing first, we need to create a new task. Then we delete a task. And finally, we use findTaskById in order to retrieve a task with its identifier, and to check that actually a result of this findTaskById would be an empty optional. In other words, that we verify that task was successfully deleted. So first thing first, let's copy this line of code. This is a definition of a DTO object. And let's now create a verify code block. So first thing first, we call repository createTask, and we pass here the task DTO. The next step would be using a compose in order to build a sequential composition pipeline. So here we have a result of createTask operation. So first thing first, let's call an assertion, say assertions, assert equals, and we need to check that task DTO ID is equal to 1. Now we asserted that this task exists in the database because it has an assigned ID. And now what we will do, we will call delete task, remove task, method. So it's a return repository remove task, and we pass this identifier. The next step that we're gonna do, we say compose. And now what we are going to do, we will pass another method here we called repository findTaskById, and we pass here ID of 1. And finally we provide handlers on failure and on success. And inside on success we have a result of this findTaskById operation. In other case it will be an optional. Let's call an assertion. We'll say assertions, assert true, and we want to check that result is actually empty, so no entity with ID of 1 exists in the database. And finally we say context complete now. So let's run this test. Now let's work on the update functionality. Here we have a definition of the task entity, because I would like to review which fields do we have. In other words, not all fields should be updated by the user. So we have here identifier, user ID, content, completed status, and created at date time. So let's start from the top. The first one would be unique identifier of a task, which is called ID. We use here a generated value annotation from GPA, and this annotation allows us to generate what is called primary key in the world of relational databases. So this is an identifier value that is used by the database in order to distinguish one entity from the another. Of course, we would not give to the user an ability to modify this value. The second one would be user ID. This value keeps an information about the current owner of the task. And if we will give to the user an opportunity to set arbitrary value here, there could be a situation when the user could get an access to entities from another user. And of course, we should not give to the user such opportunity. The content, of course, we could change and modify the value that's stored in this variable. So we could modify content of the task. Completed. Yes, we could set the task as finished. And finally, local date time, which is called createTask. So this is also a system-generated value. Rather, we don't rely on Hibernate here, and we generate this value in the Java code, in the data layer. Still, it is a system-generated value and should not be affected. So, from a technical point of view, we will allow the user to modify these two fields that we have, and we will modify them in the update operation. So let's go to our task repository implementation class. So what we will do here, we will use same ideas that we already covered in the removeTask method. So we will also create a criteria builder the same way we did before. Now we need to create a query, but unlike criteria delete, like we did in the previous step, we will call criteria update, and we also pass a type of our entity. So say criteria update. Again, we use criteria builder in order to get an instance. Next, we again create a root instance. Of course, we need to have a predicate. So far we did same steps like we did in the previous step. Unlike criteria delete, we use criteria update. Now what we will do, we will set a new property. So we say criteria update set, and we pass here a name of the attribute. First one would be a content, and we pass a new content, so say task content. Next we say criteria update set completed. And finally, don't forget to attach a predicate to our criteria update. So now our criteria is ready to go. So say completion stage, integer, so what we did here, it's basically the same what we did before. Now we create a future, and the return type would be a task DTO. So what we will do, we will return the same task that we actually passed to our updateTask method. Why we do this? Well, because if we have here an error, in other words, if we will have a problem with updating a database, we will get a failed future. So we have no necessity to manually verify a successful outcome of this operation. So we say future task DTO and we set here future completion stage, and we use a mapping. So we map this integer value to task value that we have here, and finally we return a future. So this is the implementation of updateTask method. So now let's create a test for update implementation. So let's create a new test case. We're called updateTask. So like the previous one, it also will have several steps. Let's first copy this DTO initialization code and create a verify code block. So the first step would be to create a task, because we don't have anything in our database. Let's format this code. So let's say what we have here, we again get an assertion here. We say assertions cert equals, and we set a value of 1 because we don't have anything in our database, and of course the first inserted value would be with ID of 1. We say RID. Now what we will do, we will create a new task DTO. So I say task DTO updated task, and we will create a new task DTO with ID of 1 because we now know our ID. User ID would be actually from task DTO user ID. We create a new content with say let's say updated content. The completed would be true, and the value of createTask we will get from task DTO. So say createTask. Here we also would have So now we will return repository update task, and here we pass updated task. Next step would be also compose, and what we will have here, we will have an assertions, and we will check that the completed is true, and the content would be updated content. And finally we return a repository findTasksById. Now we provide on failure handler, say context fail now, and on success handler. So again, remember that the result of findTasksById is actually an optional. So we say assertions assert true, and we say here is present, and now we could get this task DTO result. We say get it is a built-in method in the optional object in order to retrieve actually value. And what we will do now, we say assertions assert true result completed, and we say assertions assert equals updated content, and we say result content, and finally we say context complete now. So why do we actually need this findTasksById? Because if we will return back to our implementation, here we return this value, this argument. So in order to verify actually that all changes were persisted, we actually call this findTasksById, because what it will do, it will create another database operation in order to retrieve this entity from the database. So let's run this test. Let's continue with the implementation of findTasksByUser method. But before we will do coding, let's briefly go back to the documentation. And in the section 1.3.11 queries, If we will scroll down, we will find the list of different operations that could be called on query instances. So far we use this execute update, which returns a number of affected rows, but it's not the single operation that we could use. Another operation, which is very handy, and we will use this operation in this implementation, is called getResultList. So we use this operation in order to update results of the operation as a list. So if you're familiar with JDBC or just bare metal clients for Vertex, like this PostgreSQL client, you know that in the returning clauses they will return a list of rows. So row is a specific object that basically is mapping of table structure to the Java object, but it's not an entity in GPA sense. So we still need to perform manual mapping in order to create from these rows, for example, by using getIntegerValue, business entities. Here, in Hibernate, it will return a list of entities, but again, we need to perform mapping in order to convert entities to DTO objects. So, without further ado, let's go back to our IDE. And the first step we will do here, we will create a DTO mapper instance. New task DTO mapper. Then we will perform same steps like we did in removeTask and updateTask implementation. So we'll create a criteria builder. And then we will also, like we did here with criteria delete and criteria update, we will use criteria query, a specific class that allows us to create a select statement. So we'll say criteria query, and we also pass here a type. Now, what we will need to do, we need to create a predicate. But before we'll create a predicate, we of course need to obtain a root. Now we're ready to create a predicate. So, previously we did a predicate on the identifier value. Now we will create a predicate where user ID value would be equal to this user ID values, which is we passed as an argument. So we'll say root get and now what we are going to do, we will attach this predicate to our criteria query. So now we could execute this operation. We'll say completion stage, and now type would be of list task, and we'll say result session factory with transaction like we did before. We'll say session create query, and we pass here criteria query, and now we call get result list. So you see that's what we have here. We should obtain a list of tasks. However, we don't have a list of tasks. We have a task list actually class, which also needs to have a list of task DTOs. So we need to perform double mapping. We'll say future tasks list, and we'll say future from completion stage. We'll pass result here, and now what we will do, we'll perform double mapping. So first one would be mapping tasks, so list of tasks, to the list of task DTOs. So we'll say list, and what we'll do here, we will use Java streams in order to do this. We'll say list stream called map operation. We pass a mapper here, and finally we call a collector. So we collect to list. Now what we have here, we will have here a list of task DTOs. Now we need to use this task DTO list in order to create a tasks list instance. So it's a map list, and we have here new tasks list, and we pass here a list, which will be a list of task DTO. And finally, we return this feature. And basically, this is an implementation of findTasksByUser. Now, let's verify our implementation. Let's create a new test case. This will be called findTasksByUser test. And now what I'd like to do, I'd like to have several tasks. In other words, I would like to assure that our implementation could distinguish different tasks by user ID and return a correct number of values. So in our test database, we'll have two tasks that belong to the user with ID of 1 and one that belong to another user. So in order to make several operations, we need to make several createTasks operations. We will use what is called composite future. And we will say here, we'll say createTasks. And here we'll say composite future. And there are two ways, actually there are three ways. But in our situation there are two ways. So the first one would be actually any, which is not the subject of this tutorial, because with any it means that we have a list of futures, and this composite future is considered to be successfully completed if any of future is completed. So if one future is failed, that means that this composite future any is still completed. So we don't need it. We need to be sure that all createTasks operations were completed successfully, so we have a correct data set. So for this we have two opportunities. Either we use composite future all, or we will also use composite future join. It is out of the scope of this tutorial, and I cover these topics in details in my book Principles of Vertex 2nd edition, and I highly recommend you to check it if you want to get yourself familiar with reactive programming patterns with Vertex. The link for this book is in the description for this tutorial. In this particular implementation, I would use composite future join. And now we pass here a list of futures. So first one would be repository, create task for task 1. Then we say repository, create task, and we say task 2. And finally we say repository, create task, task 3. So now what we will do now, we say context, verify. And what I'd like to do, I would like to compose this createTask, because this is still a future, so it's not a list or something, it is a future, and I'd like to use sequential composition pattern in order to call findTasksByUser operation. So we'll say createTasks, compose, and here we have here this list actually of futures. So what we have here, as a result, we have a very specific situation, and we could assert that all futures were actually successfully passed. So we say assertions, and we say result is succeeded, and assertions, assert true, result is complete. Also, we are able to access each result of each operation individually. In order to do this, we need to get an object we called rList. So in our case, the result of each operation would be a task DTO. So we could print this result in order to verify that actually all our tasks were successfully inserted and all of them has IDs. So we say first one would be list get 0, and remember, because this is a list, so this is a 0-based index. The first one would be 0. Next we have rList get 1, and finally we have rList get 2. And there is a question why we actually do it like this, why we do this naive verification instead of using assertions. Well, because we have here a composite future, we could not guarantee that the first actually result this one, the first one, this one, is the result of this operation. It could be this one operation, because this is the nature of reactive programming. But what we should have here, we should have still 3 different entities, 3 different IDs. So next, what we will say, we say return repository findTasksByUser. And remember, we have 2 tasks for the user 1 and 1 for the user 2. So I will call this method for the user with ID 1. And now we say on failure, like we did before, say context fail now, and we say on success. And now on success, what we will have here, if we go back to task repository, we should have this tasks list object. So we say that this tasks list should have a list of tasks with count of 2. So we should have 2 objects here. So we say assertions, assert equals 2, and we say r tasks size. And now we say context complete now. So now let's run this test. And what we have here, first of all, we have here this tasks printed. And if we go back to our composite future, you see that the first 2 tasks would be tasks for user ID of 1. But in our output, we have here ID of 3 is actually not for this one, not for this user ID of 2, but for this one. So this is why we could not use assertions here, and we just do this naive standard output statement, because this is a nature of reactive programming. We could not guarantee that the order operation is the same as we defined like in normal synchronous programming. However, we still use this r succeeded and r is complete methods in order to verify that all futures that are combined by using this join method are successfully completed.